All right, welcome everyone. TCP and UDP ports. These are very important because TCP port represents certain applications as well of application layer. If you are aware about the OSI model, TCP and UDP port sits on the transport layer. Okay, so without taking much time, let's get to the Wireshark and analyze how TCP and UDP ports can be captured. The traffic belongs to the TCP and UDP ports can be captured. Okay, so this is our Wireshark tool, and let's say I want to look at TCP port maybe 80, so I can just type tcp.port equal to 8080. Okay, now remember there are two equal to, and then you get the TCP ports. Traffic belongs to those ports. So even if I, let's say, open the traffic, I should, in the TCP header, this is the TCP header, right? You can see the source port, destination port is 80. What you can also do is, instead of typing this here, you can also add this destination port in the filter as well. So you can apply this to the filter, and this will be taken as destination port. Okay, so this is another way of doing it. When you type TCP dot port equals to 80, this will include both source port and destination port. Okay, but if you are only taking destination port 80, that means it's mainly the client trying to reach out to the destination. Okay, every time the destination port will be covered, so most likely it would be a client communication. You only see the packet coming in from the client. Okay, so let's look at this packet. In this packet as well, you have source port, which is a random port of computer, and that 80 will be the standard port, which is where the HTTP really works. Okay, now similarly you can also do for UDP as well. You can analyze the traffic for UDP. You can just type udp.port port equals to 53, and then you can hit enter. This will take care of this. Port 53 is about DNS. Okay, so you should see DNS based traffic. Currently we don't have DNS traffic, so we won't see that. Now let's say you have a task. You want to see all the ports, all the high level overview of all the ports on which the communication has been happened. So you can go to statistics, and under here you can find the conversation. Okay, and then you have an option. You can look at TCP, and under the TCP you have these many ports, these many packets, connection being established. You can see there are a lot. So this is the system IP address, and there's the client IP address. The system A is same throughout, and system base B is also same. So all this communication happen between the same client and the same server itself. You can see the client computer, the client port number is most likely same. It has got, I don't see any changes here. So there are only two port which is used from the client side, but on the server side you can see almost all the port on which the client tried accessing or tried establishing the connection. Okay, so you can see 443, 80, and you can also find on which port the most of the data has been transferred. Okay, so you can see if you try to filter out by bytes, you can see almost on every port the same number of data has been sent. So it looks like more of a scanning attempt by the client, 29.07. So you can see port 80 is there, port 443 which is HTTPS, then again 80 which belongs to the HTTP 25.1025 and everything. So this is the way you can analyze which kind of a port has been used in your traffic analysis, and then you can apply that as a filter. You can see, if let's say I want to see all the traffic and the packets belongs to 1723 port, I can apply that in the filter. And you also have a direction from A to B or B to A, and yeah, so this is what you see, and this has been applied as a filter as well over here. You see this from machine A to machine B on source port this to destination port 1723. All right, so I hope you got the idea about TCP and UDP port. This is all for now. We'll catch you in the next video. Thank you.